Hello students, today we will discuss about accessory plate or the compensators, how they are being used to study the different optical properties under petrological microscope. Let us see what are the properties that can be studied. The properties are optic sign, direction of vibration of a mineral, sign of elongation, order of interference color, birefringence, retardation, and what are the different types of accessory plates which are being used to study these properties? They are gypsum plate, which is otherwise called as sensitive tint plate, selenite plate, first order red plate, full wavelength plate. Then mica plate. Mica plate is otherwise called as quarter wavelength plate or quarter undulation plate or glimmer plate. And the third type is quartz wedge. So these are the three types of accessory plates which are being used to identify some of the important properties of minerals such as optic sign, whether they are uniaxial positive or negative, biaxial positive or negative, their sign of elongation, whether their elongation direction is positive or negative, their direction of vibrations, their order of interference colors, their retardation value, their birefringence value, all these can be studied by use of the accessory plates. Let us know a detail about these plates. Gypsum plate is made out of a mineral gypsum. Its thickness is such that it produces a retardation of 550 nanometer, or in some cases it is 537 nanometer, and this variation is there according to the manufacturers. So commonly it is 550 nanometer, which is considered to be one wavelength. One wavelength is equal to 550 nanometer. The interference color of gypsum plate is magenta, which is the transition color between the first order and second order. Therefore, it is otherwise called as first order red plate, because red occurs at the end of each order. So between first order and second order we have the red color. Now the mica plate. Mica plate is otherwise called as quarter wavelength plate, because whenever it is being used, it either causes addition of 150 nanometer or deduction of 150 nanometer. Its retardation value is 150 nanometer. So it will either help to increase retardation by 150 or retard it by 150. And its interference color is first order white or dark grey, and it is made out of a mineral which is called as muscovite. Then we have the third type of accessory plate, which is called as quartz wedge. It is made out of a mineral quartz by cutting wedge shaped mineral matter from it either parallel to c-axis, which is called as slow wedge, or perpendicular to c-axis, which is called as fast wedge. It is because quartz is a uniaxial mineral positive where E ray velocity is less than that of the O ray, and E ray always vibrates parallel to c-axis. So it is slow ray direction. That's why the wedge cut parallel to c-axis is called slow wedge. or slow along length wedge. Similarly, the wedge cut perpendicular to C-axis is called fast wedge or fast along length wedge. So these two types of wedge can be produced by cutting the wedges from the mineral. Generally, the accessory plates which are being used in microscopes have their length containing fast direction, so that the width is the slower direction. If this is the any accessory plate, this is its length, so slow direction is parallel to width, fast direction is parallel to length. This is a common feature. It may vary. We may take fast here, slow along length, but generally the wedges are prepared or the accessory plates are prepared with slow direction parallel to the width of the wedge. Now let us find out how these plates are being used to study different properties. First we will study the optic sign. How optic sign is being determined. First we will talk about uniaxial minerals. In order to study the optic sign, we take use of the interference figure, uniaxial interference figure, and it is the basal section interference figure. In case of basal section interference figure, what happens? There is a black cross which is called an isogyre, and around it the colored rings are there. And anywhere we draw the tangent to these circles, that will indicate the O ray vibration direction. O ray vibration. And radial lines they indicate the E ray vibration direction. E ray vibration direction. So this we have to remember. So let us take one uniaxial. Let us take this uniaxial interference figure, and the mineral belongs to uniaxial group, and the figure is uniaxial interference figure. And in order to determine optic sign, we have chosen the gypsum plate. Gypsum plate is otherwise called as first order red plate. Its action will be to raise the interference color from red to first order red to second order side, or from first order red to first order side. So what happens here? Let us see. So this is the slow direction. Slow is parallel to the width, and in this condition it is being pushed along the southeast quadrant. So this is the first direction. Elongation direction is the first direction, and this is the E ray vibration direction. And here there has been blue in southeast and northwest quadrants. So blue means the color from red has been increased to blue. So in southeast and northwest quadrants there has been help, because of which there has been a rise in interference color. So the first of the accessory plate, so this is the first direction of accessory plate, is coinciding with the first of mineral. Otherwise, this color rise would not have taken place. Fast rise, slow rise. Opposite indicates fall. So here there has been blue color there has been rise, and the pushing direction of accessory plate is fast. So the E ray direction must have to be fast. Then only there will be rise in color. So E is fast, O slow. That means it is uniaxial negative. This is negative. If the gypsum plate is pushed with its elongation direction slow, then and it is found that the blue is occurring in southeast and northwest quadrants. So there has been a help in northwest southeast quadrants. So accessory plate has slow. Plates shows slow ray. So slow ray. This is slow ray of accessory plates. And here there has been increase in color. So E ray must have to be slow. It must have to be slow. So slow, there will be rise. So E has been slow. So E is slow. That means O is fast. So it will give rise to positive mineral. Here gypsum plate presents length slow. When inserted, it causes rise in color in northwest and southeast quadrant. So slow of the plate has coincided with the slow of the mineral. That means E ray is slow, O ray is fast. This is positive. Mica plate. Mica plate causes a retardation of 150 nanometer. It will either increase by 150 nanometer or cause decrease by 150 nanometer. And the interference figures are generally thin near the center. Thin. So if there will be help, there will be no compensation. If there will be cancellation, there will be the retardation spot. So these are the retardation spots, or we can say these are the compensation spots. So here mica plate has been inserted with its fast direction. This is fast, and these quadrants into which the fast has been pushed shows fall, shows compensation, shows fall. That means the fast of the mineral, fast of the plate is coinciding with the slow of the mineral. The slow of the mineral is here E ray, slow, O fast, so positive. Positive. So this is a case of positive sign. Let us take the elongation direction of the accessory plate to be slow. The compensation spots is found here. So along this there will be fast direction of mineral. So that fast slow they will cause compensation. So E, this is the E direction. So E is fast, O slow. So this will be negative. So we should simply remember that whether the pushing direction is fast or slow, accordingly we will decide. Then quartz wedge. Quartz wedge is gradually thicker. So once it is being pushed, so it will cause rise in interference color. That means when it helps, more color rings will be produced. As it is being pushed, more color rings will be produced and they will appear as if they are moving inwards. And in opposite quadrants, the number of color rings will become less and less. It will become less. Here there will be many color rings. So in the quadrants, when the color rings move inwards, it indicates rise. So the slow direction has been pushed and there has been rise here. So this must be slow. So E is slow, O fast, then positive. And if we have taken this direction as slow, this direction as slow, then this pushing direction is fast. So it is parallel to E. Here there is fall. So fast of plate must be coinciding with the slow of mineral. Slow of mineral means E slow. That means O fast. That means positive. Then let us see biaxial minerals. In case of biaxial minerals, we take use of the acute bisectrix figure. Acute bisectrix figure means the interference figure is produced by taking mineral sections perpendicular to the acute bisectrix. If this is a biaxial mineral and these are the two optic axes, then this is 2V. The 2V may be bisected by X or Z. So if this is acute angle, this will be obtuse angle. So obtuse angle is caught by one axis, acute angle is caught by one axis. And the section is caught like this, because this is the acute bisectrix. Acute bisectrix. So this section is cut like this. So it contains the two optic axes. So here these are the two optic axes or the melatops, and this is the bisector of acute angle. So here the bisector is perpendicular to the plane of this paper, and this direction indicates this X. This is the line. This is the line which contains the two optic axes. It is called as the optic axial plane. Optic axial plane, or this is otherwise called XZ plane. So this is the trace, because the section is like this. So this line is the trace of the XZ plane. So this line is the trace of the XZ plane. If X will be here, Z will be perpendicular to it. If Z will be here, X will be perpendicular to it. This is the theory. So the acute bisectrix figure presents a feature like this in 45-degree position. And let us see that the gypsum plate is being used with its far direction, like this. And here, in order to utilize the accessory plate to find out the figure and decide whether it is positive or negative, the color in the middle between the melatops, that area to be studied. So here it is yellow, here it is in blue. Blue is a case of rise, yellow is a case of fall. In the middle between the melatop there is in fall, and here the slow is like this. So slow is, this is the slow of plate. Here it has been, here the color has been yellow, so there is a fall. So slow of the plate will be parallel to the fast of the mineral. So the direction of will be the fast, which is the y direction. This is fast. So this one will be the slow direction. Slow means z. So the perpendicular to this section will be x. So x will be the acute bisectrix. That means it is negative, biaxial negative. In BXA, color in the area between the melatops is seen because it represents one quadrant. Here color has shown fall in the middle. So slow of the plate has been opposed by the fast of the mineral. Fast of the mineral, this is fast of the mineral. Fast means x. So this is x. So this will be z. So perpendicular will be the acute bisector. Acute bisector will be x. So vibration. So along axial trace of xz, the direction is z, and bxa therefore is x, and it is negative. Here the fast direction has been pushed. This is fast. Between the melatop there has been yellow. Between the melatop there has been yellow. Or this is the slow. This is the slow direction. So here it is the slow. Slow of plate. Slow of plate. But there has been yellow. So minerals, this direction will be fast. Fast of mineral. So this is fast of mineral. So this is parallel to xz plane. So it is x. Fast means x. So perpendicular to it will be z. So z is the bxa, that is positive. So we will see. So very easy to identify. First we have to see what is the direction of the plate. We will see the color inside. So this is fast. So here, so wedge is, the plate is fast, and the color has been blue. So mineral will be, this will be fast. Fast there will rise. So this direction is fast. That means it is x. So perpendicular to it will be bxa. This will be z, is positive. Very easy to identify. Now order of interference color. You have to determine the order of interference color. Generally quad wedge is used. Quad wedge is used, which is gradually thicker. So first the mineral is kept in the position of extinction. Then it is rotated 45 degree either way, along this direction or that direction. So when the mineral is in the position of extinction, the vibration action of the mineral section coincides with the vibration action of the nickels. So when it is rotated by 45 degree, one of the vibration direction will be like this. So one of the vibration direction will be parallel to the slot direction. This will be like this. So when the far direction of the accessory plate is being pushed, and the order of interference color is noted before pushing, and after pushing, if the color changes forward from first order to second order, or from second order to third order, or we can say the color changes from yellow to green to blue, yellow, then green, then blue. It is indicating a fall, because we have the order like this: gray, white, yellow, red, then blue, green, yellow, red, then blue, green, yellow, red. So here it is yellow, then green, coming like this, then blue. So it is coming like this. So this is a case of fall. As the quartz is being pushed, color changes from yellow to green to blue. So this is a case of fall. If the color changes sequence is yellow to red to blue, yellow, red, blue, this sequence, this is a case of rise. So it is a case of rise. So we know, now we could know whether there has been rise or fall. So if there is rise, fast has matched with fast, slow with slow. We know this is slow. So this direction will be slow. This direction will be fast. So slow has matched with slow, fast has matched with fast. So there has been rise in color. If there will fall, otherwise the other will be the effect. So now we could determine the direction, whether it is fast or slow. But our aim is to find out the order of interference color. So in this case, we will see when the color is showing fall, because rise will not help to find out the order. We should see whether there is a fall. So if it is showing rise, rotate the stage by 90 degree. If this is slow, now this will come to here. Now fast will become parallel to slow. So there will be fall. There will fall. So color will gradually go down like this till it reaches gray, dark gray of first order. It will reach the dark gray. If the color rising, then it will be rotated by 90 degrees, so that fall of sequence will appear. Now in fall situation, quartz is gradually pushed till dark ash gray color is seen. This is the position of compensation. That means the mineral and the accessory plate both cancel each other now. Retardation is 0 now. So in this position, further pushing of the quad wedge should not be there, because both are balanced now. Then the mineral placed on the stage is being removed and the quad wedge is gradually withdrawn, and the number of red bands that pass when the quad wedge is removed gradually, that is being noted. If no red band pass, then 0 plus 1, this is first order. If one red band passes, then the order will be 1 plus 1, that will be second order. If two red bands pass, 2 plus 1, this will be third order. So interference color in this manner is determined for any mineral. So first the mineral is kept in the position of extinction, it is rotated by 45 degree either way, the quad wedge is pushed, the color rise or fall is noted. Rise will not help. Again, if it is showing rise, then the stage is rotated by 90 degree, so that the opposite vibration direction will coincide, so that first will come in contact with the slow, there will be fall. In this condition, the quad wedge is gradually pushed further and further till a dark band or a dark grey color is being seen. That is the position of compensation. Both balance each other, mineral and plate or the wedge, they balance each other. Further pushing is not being made for the wedge. Now the mineral on the stage is being removed, and gradually the wedge is pulled out by noting the number of red bands that pass. If no red band passes, then it will be first order. The order will be first order. If one red band passes, it will be second order. If two red bands passes, then it will be third order. So in this manner, the quad wedge is being used to determine the optic sign. Vibration direction. Similarly, in order to know the vibration direction of mineral section, the mineral is kept in the position of extinction. Then the accessory plate is being pushed. No. First the mineral is kept in the position of extinction, then it is rotated 45 degree either way, so that the vibration direction of the mineral will be parallel to the slot. So in the slot, the accessory plate will be pushed. So we know this direction of the accessory plates. So what will be this direction? That can be known. If it is slow, if it becomes slow, then color will rise, and this will be first direction. If slow matches, color will become rise. If slow matches with the fast, then color will fall. That means this side, this direction is not matching with the slow direction. When there is a fall, slow is not matching with slow, so this direction will be fast. Then other direction will be slow. So by noting down the vibration direction of the mineral, noting down the vibration direction of the plate and comparing it to that of the rise or fall of interference color of the mineral, it is possible to find out whether this direction of the mineral is fast or slow, because two vibration directions are mutually perpendicular. So this direction is kept parallel to the slot. So accessory plate is being pushed. If it is slow, If there is rise in color in this condition, then this is slow. Then this will be fast. So this direction is find out in mineral. So if this is a mineral, so this direction, whether it is fast, then it will be slow. So in any mineral section that we take, its vibration direction can be detected by use of these accessory plates. Similarly, the sign of elongation. Generally, the minerals are found to be elongated in shape. If this is like this, so this is showing elongation in this direction. So this direction we have to study. So first the mineral is kept in the position of extinction. Let us say it is in this condition, it is becoming extinct. That means the vibration direction is like this. So here these are the vibration directions. So to elongation direction, whether this is closer or this is closer, that we can find out, because we will identify this one or this one. If this becomes slow, this will become fast. So as the elongation direction is not exactly matching with this direction, in that case the closure angle is being taken. If the slow is making a smaller angle, then this direction is generally called as slow. If it is matching, it's okay. If it is not matching, the smaller the angle to the vibration direction, that is being considered, and accordingly this elongation direction is being decided whether it is fast or slow. So let us keep the mineral in the position of extinction. It is elongated mineral. Let us say it is elongated mineral. In this condition, it is showing darkness. So rotate it. So it will be in this position now. So one of the vibration direction is like this, one of the other vibration direction is like this. Along this direction, the accessory plate is being pushed. This direction we know. If it is fast, the interference color of the mineral is being noted down. If by pushing it the order changes or rises, then this fast has been favored by this direction which is fast. So there has been rise in color. So fast color rise. If it will indicate slow, then the color will fall. So this direction will be slow. So when they help each other, this direction will match with this direction, and this direction we know it is fast. So this will be fast in case of rise. In case of fall, this direction will be slow. If this is slow, this will be fast. If this is fast, this will be slow. So in this condition, we can know what is the sign along the direction of length of the mineral. If it is determined that length is fast, length slow positive, length fast negative. That is the rule. Slow long positive, slow along length, slow fast, slow long positive, fast long negative. So slow along length. If this is slow, then positive. If it is fast, fast along length, it is negative. If the If by keeping the mineral in this position, the mineral is not found to be dark, it is like this, then a little rotation will make it dark. In that case, in the position of extinction, the mineral will not be parallel to the cross wires. When the elongation is not matching with the elongation direction is not matching with the vibration directions, then it will be little bent like this. So our objective is first we keep the mineral in the position of extinction. So extinction will take place in this position. It is rotated 45 degree. So the mineral will be in this position, the vibration direction will match. Vibration direction will be matching with the slot direction, this slot direction. So here the accessory plate is being pushed, color is noted. So this direction of the mineral, if it is slow, if the color rises, now this direction is slow. So this direction is found to be slow. So this is fast. Then this is the elongation direction. So this is fast, this is slow. Whether this angle is small or this angle is small, that is being taken. If this angle is 30, then this angle is, let us say it is the elongation direction. With the elongation direction, this is the elongation direction. This is one vibration direction. This is another vibration. Whether this is small or this is small, the small angle is being considered. If this is small, then this will be fast. If this is let us say it is 60 degree, it is away from this direction, 60 degree away. This is 30 degree away. So fast is closer to the elongation direction. So it will be considered as nearly fast. So fast along length. Where it matches, no problem. Where the vibration direction matches, no problem. Where it is being bent little away, not parallel to the length. So in that case, we have to determine these directions, then we will establish the relation with this elongation, whether this angle is small or this angle is small or this angle is small. Smaller the angle, the vibration direction which makes the smaller angle, that vibration direction becomes the vibration direction of the elongation direction. So we determine the elongation direction of the vibration direction, and accordingly we follow this rule: slow along length positive, fast along length negative. Then we go for the determination of bireference retardation, how they are being determined. For that we take use of the Michael-Levy chart. In Michael-Levy chart, there are three types of lines: vertical line, which links the color with the retardation value; horizontal line links mineral thickness; general thickness, which is useful for optical study, is 0.035 mm. Then radial lines, which indicate the bireference value. So these three lines are there in the Michael-Levy chart. So this is a general small simple diagram. This is the retardation value noted here: first order having 550 nanometer, second order 1100 nanometer, third order 1650 nanometer. This is the bireference. This is the retardation value. Here it is thickness, and we have the thickness lines. Generally, this line is being taken as the useful line, and we have these the vertical lines which link the color with the bireference with the retardation value. So first order red will have the retardation 550 nanometer. Second order red will have the retardation 1100 nanometer. This line. So in order to determine the bireference value, so first order red, this is first order red. So red line, then bireference, then the thickness line, they touch here. Along this point, which radial line is passing and what is its value? Generally, first order red presents 0.015 value, second order 0.030 value, third order red 0.045 value. So these are such lines. So line intersection of this one, and this one is being taken, and here in the chart, Michael-Levy chart, these values have been mentioned. So our aim is to first determine the order, then color. Then we have to search the diagonal lines and vertical lines to find out the bireference value and the retardation value. Let us say a mineral is showing second order blue of second order. So this is the vertical line. So its retardation will be more than 550 nanometer. So it will be 550 plus, because this entire range is 550. So this is one segment. There are another segment, 4 segments are there in 550. So this will be 550 plus 550 by 4. This will be the retardation for second order blue. If we talk about second order green, it will be 550 plus 550 by 2. This will be the retardation. And what will be its interference? What will be its bireference value? So first order red is 0.015, second order red is 0.03. So range is 0.015. So this range has been divided by 4 colors: blue, green, yellow, red. So each order will be having this much value. So if it is showing first order, second order blue, then the bireference value will be 0.015, because this first order red shows 0.015 bireference value. Then it will be more than that because it is second order blue. So one segment has passed. So it will be 0.015 divided by 4. This will be the bireference value. If we take about green, then this will be 0.015 by 2. If we take yellow of second order, it will 0.015 by, it is 3 by 4. It will be 4 times divided to divided by 4, 3 times. So this will be the bifrequency value. If it is reared of second order, it will be 0.030. So in this manner we utilize this Michael-Levi figure to find out the birefrequency value that has been described here. Second order birefrequency ranges from 0.030. It has the 550 nanometer to 11 nanometer. We have found out second order blue interference color. So the blue vertical line is considered along with 0.035 thickness line, horizontal line, and the diagonal line that passes through the intersection of above horizontal and vertical line. So this is the vertical line, this is the horizontal line, this is the diagonal line. So here it is mentioned in each diagonal line the birefrequency value has been mentioned. So that can be directly read or it can be found out. The birefrequency will be 0.015 plus 0.015 by 4. As blue, green, yellow, red, 4 colors present in second order in sequence. First is the blue. So 0.015 by 4. If it would have been second order green, then 0.015 by 2 would have been added. If it is yellow, then 0.015 plus 0.015 into 3 by 4. That would have been added. So in this manner, the birefrequency value is being determined, and according in the same manner also, the retardation value is being determined. First order is ending with first 550 nanometer, second order with 1100. So in between this will come. If it is blue, one segment, then 550 by 4 it has been divided, added, it becomes 685. If it would have been green, then it would have been 550 by 2. This would have been added, and accordingly it would have been more. So in this manner we determine the birefrequency value, we determine the retardation value. So this is all about the uses of the accessory plates, how they are being used, and that I discussed in a brief manner. I think it will be useful to you all. Thank you all for your patient hearing.